We now discuss the solution of a problem from the section Sequences and Series. This question has appeared in the CSIR National Eligibility Test held on 16th September 2022. The problem is related to Fibonacci sequence. The given question is, consider alpha is equal to 1 plus root of 5 whole by 2 plus beta is equal to 1 minus root 5 whole by 2. Define a sequence of numbers Fn as follows. Fn is equal to alpha power n minus beta power n by alpha minus beta for n is equal to 1, 2, 3, etc. Let P be a function from R to R, be a polynomial of degree at most 2 such that P of 1 is equal to f of 1, P of 3 is equal to f of 3, P of 5 is equal to f5. P of 1 is equal to f1, P of 3 is equal to f3, P of 5 is f5. Which of the following statements are true? We are given 4 options. Option 1, Fn is equal to Fn minus 1 plus Fn minus 2 for n greater than or equal to 3. Option 2, P of 7 is equal to 13. Option 3, Fn is equal to Fn minus 1 plus 2 times Fn minus 2 for n greater than or equal to 5. Option 4, P of 7 is equal to 10. We are given alpha and beta, where alpha is 1 plus root 5 by 2 and beta is 1 minus root 5 by 2. A sequence of numbers Fn are defined as Fn is equal to alpha power n minus beta power n by alpha minus beta for n is equal to 1, 2, 3, so on and so forth. And we are also given a function P, a polynomial function from R to R, defined as a polynomial degree at most 2, such that P of 1 is f1, P of 3 is f3, P of 5 is f5. Then we have to discuss the validity of the 4 statements that are given in this, and it is from the section. The question is from the section C, and there can be more than one option true. Agreed. That's our given question. Let's now discuss the solution of the problem in detail. A sequence of numbers Fn is defined as Fn is equal to alpha power n minus beta power n by alpha minus beta for all n belongs to a set of natural numbers, where alpha is equal to 1 plus root 5 by 2 and beta is equal to 1 minus root 5 by 2. Now, alpha minus beta, you subtract beta from alpha, you will get 2 root 5 by 2, that is equal to root 5. Then Fn will be alpha power n minus beta power n by alpha minus beta is now root 5, therefore 1 by root 5 into alpha power n minus beta power n for all n belongs to n. And we suspect these Fn's are Fibonacci numbers. Let's now compute f of 1. Note that put n is equal to 1 in this, f of 1 is equal to 1 by root 5 into alpha minus beta, which we have already seen as root 5. 1 by root 5 into root 5 is equal to 1. F of 1 is 1. So put n is equal to 2. Then you will get f2 is equal to 1 by root 5 into alpha square minus beta square. That is equal to 1 by root 5 into alpha square is 1 plus root 5 whole square by 4 minus beta square is 1 minus root 5 whole square by 4. That 1 by 4 we have taken common, and 1 plus root 5 whole square minus 1 minus root 5 whole square is equal to 4ab, a plus b whole square minus a minus b whole square, that is equal to 4ab, that is 4 into 1 into root 5, that is 4 root 5. So 1 by root 5 into 1 by 4 into 4 root 5 cancel and you will get 1. So f of 1 is 1, f of 2 is 1. Thus we get f of n is equal to 1 by root 5 into alpha power n minus beta power n, and n greater than or equal to 3, and f1 is equal to 1, f2 is equal to 1. Yes. We continue in the next slide. So that's what we have done so far. Now note that this alpha and beta are the roots of this quadratic equation, x square minus x minus 1 is equal to 0. It's very easy. Now alpha, and what is that quadratic equation? Whose roots of alpha and beta? This is precisely this one. So alpha beta are the roots of this one. Therefore alpha square is equal to 1 plus alpha, beta square is equal to 1 plus beta. Agreed. Now let us take the option 1. Let's see the validity of this statement. So fn is equal to fn minus 1 plus fn minus 2 for n greater than or equal to 3. This is the Fibonacci condition. Agreed. Now for n greater than or equal to 3, fn minus 1 plus fn minus 2 we write down. Fn minus 1 will be 1 by root 5 alpha power n minus 1 minus beta power n minus 1 in brackets, plus fn minus 2 is 1 by root 5 into in brackets alpha to the power of n minus 2 minus beta to the power of n minus 2. Now between this alpha power n minus 1 and alpha to the power of n minus 2, take alpha to the power of n minus 2 is common. So if you take alpha power n minus 2 common, then you will get 1 from here and alpha from here. So alpha to the power of 1 by root 5 in brackets alpha to the power of n minus 2 into 1 plus alpha minus, in a similar fashion take out beta to the power of n minus 2 common, and that will be multiplied by 1 plus beta bracket close. Right, and we have already seen 1 plus alpha is alpha square, 1 plus beta is beta square. Substitute that, then 1 by root 5 multiplied by alpha to the power of n minus 2 into alpha square minus beta to the power of n minus 2 multiplied by beta square, that is equal to 1 by root 5 multiplied by alpha to the power of n minus beta to the power of n, which is fn precisely. So thus we got for n greater than or equal to 3, fn minus 1 plus fn minus 2 is equal to fn. Thus the option 1 is true. Agreed. When option 1 is true and f of 1 is 1 and f of 2 is 2, and we can write down the Fibonacci sequence. Now the Fibonacci sequence fn n is equal to 1 to infinity is 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 3, 5, 13, so on and so forth, which is precisely the Fibonacci sequence. Yeah, that's what we have done so far. And now let's call the option 3. F of n is equal to f of n minus 1 plus 2 times f of n minus 2 for n greater than or equal to 5. Is it true? That's the question. Now this is the statement is for n is greater than or equal to 5, and the Fibonacci's rule is valid for n greater than or equal to 3. Therefore the Fibonacci rule is also valid for n greater than or equal to 5. So for n greater than or equal to 5, fn is equal to fn minus 1 plus fn minus 2. For n greater than or equal to 5, if the option 3 is true, fn is equal to fn minus 1 plus 2 times fn minus 2, which is not true. Therefore this is not a true statement. So to say so, we first note down that f5 is 5. f5 is 5. Agreed. Now in this, put n is equal to 5. You will get, assume that the above one is true. Then f5 is equal to f4 plus 2 times f3. f4 is 3 plus 2 times f3 is 2. So 3 plus 2 into 2, 3 plus 4, 7, a contradiction. Why? f5 is 5. But now if you say that this option 3 is true, then F5 will be 7, a contradiction. Therefore, the option 3 is not true. We continue in the next slide. That's what we have. And given P is a function from R to R, which is a polynomial of degree at most 2. And it is further given P at 1 is F1, P at 3 is F3, P at 5 is F5. And let P of x is equal to ax square plus bx plus cy. It is a polynomial function. It's a polynomial of degree at most 2. So now put x is equal to 1. P of 1 is equal to a plus b plus c. That is equal to, given to be f of 1. F of 1 is 1. And P of 3 is given. P of 3 is 3 square a, 9a plus 3b plus c is equal to f3. F3 is 2. Right. P of 5 is 5 square a, 25a plus 5b plus c is equal to f5. F5 is equal to 5. So we have 3 equations and 3 unknowns. And we take these 3 equations, and solving these 3 equations, we get the values of A, B, C. The values of A, B, C are A is equal to 1 by 4, B is equal to minus 1 by 2, C is equal to 5 by 4. Take these values and put it in P of x. Then P of x is precisely equal to x square by 4 minus x by 2 plus 5 by 4. This is the polynomial, required polynomial. Now what is that we want? We want option 2, P of 7 is equal to 13. Option 4, P of 7 is equal to 10. Now normally a student is tempted to say P of 1 is equal to F1, P of 3 is F3, P of 5 is F5, therefore P of 7 is F7. So P of 7 is F7 means F7 is 13. So he is tempted to say option 2 is right, but this is not true. So now take this P of x and put x is equal to 7. Now P of 7 is equal to 7 square by 4 minus 7 by 2 plus 7 by 4. Take the LCM. The numerator is 49 minus 14 plus 5 by 4. Simplify 40 by 4, that is equal to 10. So P of 7 is equal to 10. That is option 2 is true. Option 4 is true. Option 2 is not true. Option 2 is not true. So if someone guesses that P of 7 is F7, therefore 13, that is totally wrong. So if P of x is given by this formula, so according to this formula, you will get 10. Agreed? So what is that we have? Thus, option 4 is true and option 2 is not true. So summarizing all these things, option 1 and option 4 are true. The answer to this question is option 1 and option 4. That is the detailed discussion of the solution of the problem on Fibonacci sequence. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.